Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. In this video, I am going to find out the distance traveled by a point on the rim of a wheel that is rolling without slipping in one complete rotation. The beauty of mathematics when combined with physics is going to be revealed in this video. So follow the video till the end, observe each and every step that I am going to do. Consider a wheel which is rolling. That is, the center is translating with a linear velocity v, and about the center, the wheel is rotating with angular velocity omega. The axis of rotation is translating, and the body is rotating about the axis of rotation. This is rotation plus translation, or otherwise known as rolling motion. And the point of contact is not slipping on the ground, so this is rolling without slipping. And as long as v and omega remains constant, it is uniformly rolling without slipping. So uniformly rolling and rolling without slipping. In this case, if you observe any point, so I am taking point P, which is at the bottom initially. The path traced by that point is represented by this pink color path. In half a rotation, P goes to the top, but by the time P goes to the top, the wheel has got some horizontal displacement. In full rotation, the P will again come back to the bottommost point. So by the time the wheel has got some horizontal displacement. So wheel is tracing this path is known as cycloid. I am going to find the length of this path or the distance traveled by that point P. So let us get into the derivation. By relative velocity, velocity of any point P with respect to C. So center C, with respect to C, if I observe the velocity of any point, velocity of point with respect to C is Vp bar minus Vc bar. So velocity of any point of rolling motion is velocity of that point with respect to center plus velocity of center. This is the equation that will help us to find the velocity of any particular point of a rolling body. With respect to center, it is pure rotation. So if you observe the bottommost point, with respect to center, it has got a velocity of r omega towards left because angular speed is in clockwise direction, plus velocity of the center, that is v. The velocity of the bottommost point is v minus r omega, as you can see. That must be equal to 0 because it is rolling without slipping. The point of contact is not slipping with respect to the ground. So velocity of the point of contact must be 0. V is equal to r omega is the condition for no slipping in this case. Say this point P after some time has gone somewhere here. So initially point P is here. After some time, point P has got angular displacement of theta. So theta is equal to omega t. Let me say this happened in a time interval t. Theta is equal to omega t, as omega and v are constant because it is uniform pure rolling. The meaning of uniform pure rolling is the linear velocity of the center and angular velocity above the center remains constant. So theta is equal to omega t. Anyhow, the point P is here after some time t, and the velocity of that point P is velocity with respect to the center, that is r omega, where r is the radius of the rolling body, plus velocity of the center, that is v. The resultant of these two velocity components is the velocity of the point P, and the magnitude of that velocity is the speed. Let us first find the magnitude of velocity of point P at any arbitrary position. The angle between V and r omega is, I'll try to find that out. So I am drawing a vertical then horizontal. If this angle is theta, this is theta. So this would be theta. If I resolve r omega, the component of r omega along horizontal is r omega cos theta, and along vertical it is r omega sine theta. The velocity of the particle P, Vp bar, is now V minus r omega cos theta I cap plus r omega sine theta j cap. The magnitude of velocity of the particle is under root V minus r omega cos theta whole square plus r omega sine theta whole square. So this is root over V square plus r square omega square cos square theta minus 2V r omega cos theta. This is the expansion of a minus b whole square plus I have r square omega square sine square theta. So V square plus r square omega square cos square theta plus r square omega square sine square theta, which is r square omega square into cos square theta plus sine square theta, that is 1. It is r square omega square minus 2 V into r omega. Because r omega is equal to V, so I can write 2V square cos theta. So that is, again, r square omega square can be expressed as V square plus V square 2V square minus 2V square cos theta. That is equal to V into under root 2 into 1 minus cos theta. V into under root 2 times 1 minus cos theta can be expressed as 2 sine square theta by 2. So this is finally 2V sine theta by 2. The magnitude of velocity of a point P is 2V sine theta by 2. This is the final result of the magnitude of velocity of point P. Because we got to know the speed as a function of theta, and theta is varying with time, so we got speed as a function of time indirectly. Theta can be written as omega t, so speed of the point is 2v sine omega t by 2. So we found velocity of this point P. It is a resultant of v and r omega. It is in this direction. So that is the reason why the path of this point P is cycloid. With respect to ground, if you observe the path traced by this point, it would be a cycloid, as we saw initially. Now we know Vp, that is 2V sine theta by 2. Theta is equal to omega t. So Vp, that is equal to 2V sine omega t by 2. Take a small interval of time dt. In that small interval of time, this point P has got a very small distance. So in this direction, it has got a very small distance. So ds is equal to Vp into dt. That is equal to 2V sine omega t by 2 into dt. That is equal to small distance traveled by that point P in time dt. I am integrating this on both sides. Time t is equal to 0 to one time period t, that is equal to 2 pi by omega. One time period is the time taken to finish one complete rotation. The total distance traveled is from 0 to s. So LHS is s, that is equal to 2v, these are constants. Integration of sine omega t by 2, that is cos minus cos omega t by 2 by omega by 2, and the limits are from 0 to t. So this becomes 4v by omega, and I'll take minus also out. The upper limit is cos omega t, capital T by 2, minus lower limit is cos 0. That is minus 4 v by omega, because it is pure rolling, v is equal to r omega. So v by omega is r, so I am substituting r instead of v by omega. cos omega into t. T is equal to 2 pi by omega. So omega into t is 2 pi. Omega t by 2 is pi. Cos pi, that is minus 1, minus cos 0, that is 1. So this is minus 2 minus of minus plus 2 into 4r. Finally, the distance traveled by the point P on the rim in one rotation is 8r. With this knowledge, you can try to find out what is the displacement of the bottommost point in half a rotation. You can also easily find out what is the displacement or the distance traveled by the center of the wheel in one time period. These are very simple questions. You can try and get the answers, and you can use the comment section to post your answers.